Good afternoon, Rich Nass, Executive Vice President with Open Systems Media and leader of the Embedded Computing Design franchise. Here for another of a series of videos, 8 videos in total that we are doing in conjunction with PICMG to help launch the COM-HPC specification. This is one of the biggest things to hit the embedded computing industry in a while. So we're hoping that you'll learn something from these videos. Each of the 8 videos looks at a different aspect of the new COM-HPC standard. This video we're shooting with Intel. We actually have 2 different speakers from Intel who'll be helping us out today. One is Pawitter Bhatia, and the second is Joel Finkel. And in just a second, I'll let them introduce themselves. So first, here's Pawitter.
Hey, thanks, Rich. It's Pawitter Bhatia. Thank you for the introduction. I am a product line manager, specifically targeting Xeon products within the IoTG group at Intel. And Joel?
Yeah, and I'm Joel Finkel. I am a customer engineering architect, as well as a manager for a group of customer engineers that work with our key strategic customers for design-in.
Thanks to both of you. So would you explain to me what the audience can expect to learn from this video?
I'll start first. So this session that we have on the investment protection and scalability with COM-HPC, I will be doing a brief introduction on how COM-HPC is useful and extends the benefit of what we have seen with the COM-Express designs or form factors today. And then I'll hand it over to Joel, who's going to speak on the scalability and protection, investment protection. Welcome to this session on investment protection and scalability with COM-HPC. In this session, as I spoke before, we will discuss how COM-HPC helps deliver the portfolio scalability to share investment costs and extend system life for diverse IoT and edge market. IoT is transforming the way we are living and working today. A lot of the companies and enterprises are deploying autonomous decision-making capabilities, as well as consolidating the different workloads at the edge. These trends are driving the need for different system profiles, especially the high compute, to meet the requirements of the varied IoT and edge systems. The COM-HPC is a new modular standard that builds on the success of the COM-Express form factors. COM-HPC supports a higher number of faster IOs, such as PCIe Gen 5 and larger PCB design sizes to accommodate server CPUs and additional components. It is designed to meet the compute, memory, and IO requirements of the emerging AI, deep learning, 5G, and edge applications. COM-HPC, with its modular architecture, enables design choice flexibility for easy scalability and upgradability. Let's look into the graphic on the left, which shows the COM-HPC different board size options that are going to be available. The table on the right has a few examples pairings of COM-HPC to some Intel products and memory configurations. Do note that the other design permutations are possible, like using memory down configuration or using a different CPU, such as a core desktop CPU in a client size. COM-HPC size A board is comparable to COM-Express basic size, which can be used to fit an Intel client or a server product. COM-HPC advantage over COM-Express is that it provides more space for additional components, such as memory, VPUs, FPGAs, other accelerators, with the different board size options available. The largest size D and E options are designed to support standard RDIMM and UDIMM memory configurations that are typical for a server CPUs. COM-HPC also allows a direct thermal management solution for accommodating more power-intensive CPUs instead of using a heat spreader across the entire module. What this enables or opens the possibility is to create modules with either the Intel Core Desktop LGA products in client sizes or a higher compute, higher powered Xeon products in the server sizes. Overall, COM-HPC extends the design possibilities by allowing higher-end, higher-power CPUs, additional components such as memory, and more and faster IOs in comparison to COM Express. With that, I'll hand it over to Joe.
Thank you, Pawitter. Now we're going to talk about some of the scalability benefits of a COM-HPC architecture. One of the major advantages of a COM-HPC architecture is the ability to share the design investment across several end-use applications. An example is to use the same client module on a retail point-of-sale system, an ultrasound machine, or a slot machine. A second major advantage of COM-HPC is the ability to scale up and down with different module pairing options to the same carrier board. An example is an oscilloscope portfolio for test and measurement. An entry-level product may use an Intel Atom class SoC, while a mainstream version might have an Intel Mobile Core product, while an upper-end premium version may have a Core desktop CPU and chipset. Now, if we expand the concept a little bit further, what that means is there's insulation between the end application and the components on the module of the COM-HPC. In contrast to a single board architecture, if we take the oscilloscope example, you would basically be limited to one board where you can scale up and down within that CPU family. Or you'd have to do a brand new and separate motherboard design for the entry level, another for the mainstream level, and a third one for the premium level of products. Scalability in COM-HPC is not just limited to scaling up and down to meet the various power, performance, and price options for a product line. It also allows scaling forward to the latest compute products. In the graphic in the middle of the slide, there's a main system carrier board that is deployed for a few years, as you can see, from 2021 through 2023. With the initial product release, it can only come with one option with Module A paired to it. But a year and a half later, Module B comes along, and now the product line can be offered with Module A as an entry-level product or an upgraded Module B with better performance. Another year and a half later, let's say Module A is now obsoleted, and Module C comes along, but it's part of a new compute family architecture that offers new IOs such as PCI Express Gen 5. It can still be paired with that initial system carrier. However, that system carrier is designed for PCI Express Gen 4 speeds, so you're not able to get the full performance from Module C. But with a planned refresh of the system carrier, Module C can be paired with the second carrier board, replacing the first carrier, and now you can get the full benefits of PCI Express Gen 5 peripherals. Eventually, the entry-level product for Module A gets replaced with Module D, and the cycle continues further in time. For another example of how going in time works, let's juxtapose this with a single board architecture. If you have to do a product line refresh on a single board architecture, if a compute family changes, whether it's power rails or the mechanical properties or IO, you're talking about doing a full board respin. But in this case, COM-HPC can save quite a bit on the design costs as well as reduce time to market. Another advantage of the scalability forward in time is that you can extend the life of a COM-HPC deployed system. Most compute products are having a lifespan of 3 to 5 years. And by employing a COM-HPC architecture, the overall system can be deployed with one or more scheduled COM-HPC module upgrades. Now it should be clear why a COM-HPC architecture allows you to future-proof your investment. So now we've discussed how the world is changing and there's an increased demand for artificial intelligence and deep learning applications in the IoT and on the edge. And we've compared how larger module sizes of COM-HPC can help meet this new demand for higher performance compute. We've also shared some example pairings to Intel platform families. And finally, we've talked about the versatility of the COM-HPC architecture to share the design investment across a product line by scaling up and down, as well as forward in time. This allows reduced design cycles to quickly introduce new and refreshed products to the market. And with that, on behalf of Rich and Pawitter and myself, I'd like to thank you for taking the time to listen.
Excellent presentation, guys. I do have a question though. When you're talking about the slide about future proofing, does that involve any changes to the specification, or is that already in the existing, or it's already that's just been released?
It's already in the existing specification. So basically, you can have, as a new compute family comes out, you can basically just design the next module, the next module, the next module, and plug it in. Very good. Well, thank you very much. This is just another example of what you can do with the new COM-HPC spec from PICMG. Look at all the other videos. There are 7 others beside this one. Each one is looking at a different aspect of the specification. You should check them all out.